Okay, this is problem 2.4, and 2.4 says let's determine the design moment capacity for a beam that's 16 inches wide, 32 inches deep, reinforced with 7 number 10 bars. And really, here's the deal. Placed in 2 layers, 5 in the bottom layer, 2 in the top layer. And there's 1 inch clear between layers. All right. What this problem really comes down to is what D is going to be. All right. We know that moment capacity, nominal moment capacity, is given by this formula. The question in this problem comes down to D. And we already know the definition for D. D is the distance from the compression side of the beam down to the centroid of the steel. Okay? Now they tell us that this is 16 inches wide by 32 inches deep. And I would assume that they're talking total depth when they say 32 inches deep. In the italicized portion of everything, they say, for beams, assume 1.5 inch cover and number 3 stirrups. So, here's my cover down here. I'm just going to draw a number 3 stirrup in like this. Number 3 stirrups will get to this in another week or so. They're U-shaped bars, but down here, at least from the bottom, they're going to be taking up 3/8 of an inch. So I got 1.5 inches here. I got 3/8 there. Okay, and then I got this bottom layer of 5 number 10 bars. The number 10 bar is 1.27 inches in diameter. Then I've got a space of 1 inch. And then I've got 2 other number 10 bars. All right? So, that's the general setup. The deal is, though, we've got to find what D is. And D's, the centroid of the steel. Well, I'm in 2 layers. The centroid of this layer is right here. The centroid of this layer is right there. I got to find the centroid. Okay? So, how do I find the centroid? Well, this goes way back to, statics, really, when we talk about centroids towards the end of statics. But in essence, what you got to do is develop, or at least most people would develop, a little table. And the table would look something like this. Area, since I'm really only interested in the Y, where it acts from a Y direction, I really don't care about the X. I'm just going to say A, Y, A times Y. Back in centroids, when we were doing whole shapes, we said A, X, AX, and then Y, AY. But, we're only interested in this. So, up here I got an area that's got 2 bars and 2 number 10 bars. Then you told me before number 10 bar has an area of 1.27, right? So 2 times 1.27 is 2.54. Okay? If I'm interested in the distance from the top down to this centroid, what would that be? Well, let's do this. 32 minus 1.5 minus 3/8 minus 1.27 minus 1 minus 1.27 divided by 2. Okay? So I'm Somebody want to do that one for me? Minus 1.5 minus 0.375 minus 1.27 minus 1 minus 0.63. What was it? 27.2. Area times y gives me AY. What's that? Say it again, please.
69.
All right. Second layer of steel. 5 number 10 bars. 5 times 1.27 is what? 6.35? Okay. Now we've got to go from the top down to here. Well, that's 32 minus an inch and a half cover minus at number 3 stirrup minus, again, just half of the number 10 diameter. So that gives me what? Say it again, please.
29.49.
So we'll say 29.5. 6.35 times 29.5. Gives me what? Okay. You sum up the areas. Sum up the area times the y's. And the y bar distance is equal to AY. Now you've rounded this, I mean, but that's all right for what we're doing. Divided by the areas. Y bar is equal to AY divided by the areas. The sum of the AY divided by the sum of the areas. So this y distance 28.79. That's the distance from the top of the beam down to the centroid of the steel. And it should lie between these two, and it should be closer to the 5-bar layer because there's more area there. So that sort of makes sense. That, 28.79 or 28.8 is essentially, well, is D. That is the D distance there. Okay? So, I mean, really from this point forward, now you're just, plugging the stuff in. 7 number 10 bars, T, 8.89. What FY did we have here? We had 60. I'll say 60 KSI. So you got that is what? 533.4. T is equal to C is equal to 533.4 kips is equal to 0.85. The concrete strength here is 4 KSI. We're solving for A, and the width of the beam is 16. So A comes out to be what? 9.8. Okay. So now MN is 533.4. So D is, now RD that we solved for before, 28.79 minus 1/2 of A. And again, I'll divide that by 12 because this is inches. So I'll put inches in the feet. So I'll have foot kips. And again, I think it asks us for design capacity, BMN, so we're going to take that, we're going to multiply by 0.9.
952.1.
And that gives us 952.